In this video, we will look at a continuation of basic functionality of the Nspire CX CAS. Here we're going to start looking at graphs page. We're going to pick up where we left off after the calculator page. As you can see here, I've got a calculator page. Suppose I now want to actually graph something. I can insert a graph. I can do it a variety of different ways. Probably the easiest way is to hit my Control plus Page button. And then I can select what application. In this case, I'm going to add a graphs page. So I'm going to click that. And you'll notice that it comes up with f1 of x equals. And I can do this a variety of different ways. If I actually have something that's predefined, as you recall before, over here on this other page, if I click the tab, I can jump to the other page, or I can do Control left or Control right. And that takes me to different pages. But if you recall here, we had defined at the very beginning functions that say f of x was x squared. So if it's already predefined and I'm on a graphs page, I can simply type it. I don't have to retype x squared. I can type f of x. Oh, for some reason, it's wanting to give my cap locks is on, so I'm going to shut that off. There we go. So I can just type f of x. And there it is. Notice it doesn't tell you what it is, but it's x squared is really the graph that we're talking about, okay? Because it was defined over here. So across pages in a single problem, it actually knows what it is. However, if I want to break from this and I want to graph something new and I don't want to have all of my history follow me, I can create what's called a new problem within the same document. To do that, I'm going to touch on the dock key, and down here I have insert problem. You'll notice pages there as well, but I want to insert a whole new problem. And let's insert a graphs page there, and I'll show you what the difference is. So in this case, notice this is problem 1, page 1, problem 1, page 2. This means problem 2, page 1. So it no longer remembers anything from before. So if I type f of x, it says, what? I don't know what you're talking about. I don't know what f of x is. So if we want to actually graph x squared, for example, like we did before, in this case, if I double click in the white space, any white space here, it pulls up my command line, and I can hit my up arrow, and I can go up here and delete that, and let's actually type x squared. Now there's my x squared graph, and now I've got the same thing I had over here. The only difference is now it's not connected to the definition of f. Okay, it's a little bit different. The way the documents work in this device is you have documents. Inside documents you have problems, and inside problems you have pages. And across all pages of a single problem in a document, all information is shared. So if you define something on one page, you open up another page in the same problem, it will know what it is, and you can just call it by name, or you can operate on it however you want to do it. So it's a little bit different than a typical graphing calculator. The upside is you can save all your work. On a typical graphing calculator, if you wanted to start a new problem, you'd basically delete anything in your Y1, Y2, Y3, or whatever, and start all over again, and then you've lost all your work. Here, I would encourage you, when you work on homework, to actually create a new document for every homework set. And then inside that document, create multiple problems so that you can have problem, the first problem, the second problem, the third problem. You can have multiple pages when you work on those problems, but yet when you're done, you save it and all of your information is saved. So for example, in this case, suppose I wanted to save this document. If I go to my dock key and I go to File, you can go down to Save, or you can use the shortcut, which is Control S, just like on a computer. I can save it and I can put it anywhere I want. So I can put it in any folder I like. I can just have it free floating inside my documents. Let's say I just call it Document 1, Save. Okay, it has now saved this, and you'll notice that the name has changed at the top. It's called Document 1. You could call it anything you wanted. Okay. So I encourage you to always try to, when you work on homework, create a new document for each homework set. That way you can review all of your work for the entire semester, and it's all stored in your calculator. Okay, now one of the nice things I can do with this that you can't do on a typical graphing calculator is I can actually manipulate things. So for example, here's my x squared graph. I can click and grab a hold of this. If you want, on the handheld, what you would do is you would hover over top of it and you would click and hold down in the center of your nav pad, and then you'll get the little hand, it'll close, and you can grab it and move it wherever you like, and then just let go or hit escape to release it. Okay, now the nice thing I can do is I can grab a hold of the actual graph. I can morph the graph, and you can see the effects on the algebraic expression in real time as I do it. If I grab away from the center of the screen, I can morph it this way. If I grab toward the center, you'll notice that this is my dilate icon. You'll notice it turns into a translate icon, kind of a compass rose, north, south, east, west sort of icon. And this allows me now to manipulate it and move it in space without changing the fatness or thinness of the parabola. And you'll see that up here, it gives me the equation in vertex form. If I started out with something in standard form, it would actually leave this in standard form as well. So it gives me several different options. So I can manipulate it. The other thing I can do is I can manipulate my viewing window a variety of different ways. You'll notice that the standard window goes -10 to 10 on the X and -6.67 to 6.67 on the Y. This is a square window. Unlike a typical graphing calculator, one tick mark along the X default is the same distance as one tick mark along the Y. It's geometrically true. Now I can change that, however, by grabbing a hold of tick marks or clicking on these numbers and changing them. Or I can go into my menu and I can go down to window zoom and I get my window settings here, which is very similar to what you're used to seeing on, say, a TI-83 or 84. Okay, but I can also grab a hold of the page. So if I just click in the white space and hold down and then start moving it, you'll see a little hand appear, and next to the little hands, you'll notice that it's like little wrinkles of the paper. It's like grabbing the paper so that you can drag it around and manipulate it any way you want to go. Now let's say I move it over here and I say, oh no, I like it the way it was. I can just do Control Escape, that's my undo command, and it does the undo. And if I do several things and I want to undo a series of events, you just do Control Undo, Control Undo, Control Undo a couple times and it gets you back to where you were. So it's kind of nice. You've got this infinite undo capability to be able to go backwards in time and change things back to the way they were before you started screwing around. All right, so this gives me some ways I can manipulate the entire window. If I grab a hold of a tick mark, I can zoom in or out. Notice that as I pull on this, both the X and the Y tick marks are changing in the same way. If I only want to change one axis tick marks, if I click and hold on a tick mark, and then I hold my Shift key down, and again, Shift key is the key above the 7 key, and I manipulate it, now you'll notice only the tick marks on the Y-axis are changing. Similarly, if I grab a hold of an X tick mark and hold my Shift key down, I'm only manipulating the X-axis scale. So I can rescale things as well. And again, I can also go into my menu and I can go into window zoom and I can get my standard manipulation techniques here like zoom box. Right? I can rescale by saying, oh, that's the first corner. Click, there's the second corner, and it rescaled it for me that way. I can also simply go and get my zoom in, zoom out. Let's say I want to zoom out at this point. Say I want to zoom out at the center. Boom, boom. If I want to zoom in, same thing. Go get my zoom in, zoom, zoom. So this allows me the same sorts of features that you're used to seeing on a standard graphing calculator, but it also adds to it kind of a tactile way to manipulate. It's like you can grab stuff and move them around. Now, you're going to be tempted to want to actually touch the screen of this device and manipulate things like you would on an iPad or an iPhone. It can't do that by design because if there were to be a touch-sensitive screen, it would no longer be allowed on standardized tests. So it's not that the creators didn't want to do that. In fact, there's an iPad app of this as well. I think it's about $29 or something like that, where you can actually physically manipulate graphs and things with your fingers. But for the purpose of testing, they needed to keep it so that the screen was not touch sensitive. So that's the reason it's this way. So just get used to using your click key in the center here as a means to grab a hold of things over here on the keypad. So we've morphed the window a little bit, we've morphed the functions a little bit. We can also place points on things, and we can manipulate things. We can put tangent lines on. Let me just show you some features here. Let me go to Menu. Let me go down to Geometry. Let me go down to Points and Lines. And let me get my point tool. So I'm just going to click on that. You'll notice once you select a tool, an icon appears up here in the upper corner, letting you know what that tool does. So here, when I get close to something, right now I'm looking at putting a point in space, but if I get close, it says, oh, you want this point on this graph, don't you? And notice that it says point on, and then there's a tab icon. What that means is if I go over and I hit the tab key, it now is free moving. So if I click right here, the point is not going to be anchored on that graph. It's actually going to lie underneath the graph just in the plane. If I hit tab again, it goes back to my point on, and it's actually going to give me that specific point. So the tab key simply allows you to select from multiple things that could be on top of each other as well. So I'm going to click and I'm going to put a point on that graph. Now the nice thing about this, I can move this, if I want I can grab this and move it out of the way if I like. Let me move it down here. If I double click on this and I actually get inside this box, I can just type, say, for example, the number 2 and hit enter, and it will jump directly to that location. Okay, so I've got this free moving point here that I can just grab a hold of and move. But again, if I click and hold and type in a number, it will jump directly to that location. The other nice thing about it is I can actually do that with the y coordinate, which is kind of unusual. Most calculators let you do that with the x but not the y. So this does let you do that with the y coordinate as well. Okay, so now I've got the ability to manipulate and morph and move points around. Let's say, for example, I want to attach a tangent line there. Okay, if you're in a calculus class, you might want to attach a tangent line. I'm going to go down to Geometry. Tangent line is found under Points and Lines. I can go down here to Tangent. And as I move close to it, it knows what I want to do. Once I get close to that point, if I'm right here, I can click on the graph and it'll let me anchor it anywhere I want after I'll do a double click, basically. But here, if I've got a point already on there, I can just point to that, click, and there's my tangent line. Let me move the equation of the tangent line down here so we can see it. And I can manipulate this, drag them around, okay, and move them anywhere I want. So I have a tangent line there. I can also talk about finding intersections of multiple graphs. For example, suppose I want to graph another function on top of this one. Let's say, let me just double click here. Let me put a function in like minus x squared plus. So we'll flip one upside down. Let's go up to 4. Okay, there it is. Notice it gave it a separate color so we can tell the difference. Move him down here. Oh, come on, he doesn't want to move on me. Once I get down to there. Okay, let's put him right there. Okay, the other thing I can do now is I can actually find intersection points. So if I want to find where these two intersect, say here and here, I can go Menu. I can go down to Geometry, Points and Lines, and I can do a couple of different ways. If I just choose my point tool, when I get close to an intersection point, it will let me click on each one individually. If I get the command that's called intersection points, it will actually slap them all down at once. So let me try it that way. So I'm going to point to this graph, and then I point to this graph, and notice it put the points down right away. So I have both intersection points. Now, another thing in calculus from time to time we like to do is to be able to find area bounded by curves. Well, there's a nice feature. If I hit Menu and I go over to Analyze Graph, there is a command here called bounded area. I can also just use integral, and this will find the area under a curve between the curve and the x-axis. Bounded area lets me pick more than one function and find the area bounded between those two curves. So for example, I can click here, and then I can click, say, that point, and this gives me now the bounded area. Let me grab it. That's the area right there. Okay, so this shows me the bounded area. The other nice thing is I can also, select this bounded area value here, and if I want, I can manipulate my endpoints if I like. Let's say I put a point on the axis. I could allow me to find the bounded area between the two up to a given point. Okay, so anyway it goes, I could use my integral command. Let me show you the difference between that and the integral command. If I go to Analyze Graph and I go to Integral, I can say, suppose I want the integral of that graph from there over here, and it's just simply finding the area under the curve as opposed to the bounded area. So this is just dealing with the red graph at this point. Okay, similarly, I could do that with the blue graph. So I can get bounded areas and things like that. All right, let's also talk a little bit about piecewise defined functions and use of sliders and things like that. To do that, I'm going to insert a new problem so that we start fresh. So I'm going to go here to Doc, go down to Insert. I'm going to say Problem. Notice I'm going to add a graphs page. Notice it says 3.1 because this is now problem 3, page 1. If you want to kind of get a visual of where all these pages and problems are nested, if I do Control up arrow, it kind of gives me what I call a slide sorter view, like in PowerPoint, where I can scroll up and see. You can see problem 1 has 2 pages in it, problem 1 only has 1 page, and problem 3 just has 1 page. And you can just simply move around here and just simply click on whichever one you want to bring forward. So as you have a document that's got multiple problems in it, sometimes it's easier to move around from problem to problem rather than just doing Control left and Control right. It's easier to do Control up arrow and then just select the page you want. So let's take a look at a function here. Let's do f1 of x as x squared plus, and let's do bx. So I have to do b times x. Don't forget the multiplication operator here, because if I just type bx, it's going to think that bx is a multi-letter name for a variable. And then let's say plus c. Okay, so basically we have two parameters, b and c here. I'm going to hit enter. When I hit enter, the machine is going to ask me, do I want to create sliders for b and c? Because it doesn't, on the graphs page, it's really just used to having x and y. So when it sees a b and a c, it just assumes that I want some sliders, but it's going to let me choose. So when I hit enter, it says create a slider for, and if c was stored somewhere else and I don't want it to be a slider, I can just uncheck that one. But here I'm going to have the machine insert 2 different sliders for me. Okay, and these sliders then can be manipulated and moved wherever I want. And now, once I have sliders on here, I can grab the slider and I can manipulate the slider, and you'll see it move based on what b is. Right now, b starts at -5, -4, -3, -2, -1, and so on. Notice that if we actually followed the vertex of this, it'd be kind of interesting to see what path that would follow. C, on the other hand, just simply moves it up and down because it's just a number added on to the end. Okay. If I want to make these sliders move in a more fine manner rather than just jumping by one every time, I can actually go in and select the slider here and have the machine actually change the settings of the slider. So if I like, I can do menu, settings, oops, hold on a second. I want to go to Properties, Control menu. And if I want to move the slider around, if I click Move here, for example, it now lets me move it around again. But again, if I do Control Menu, I can say Settings. I want to say go into my settings. Here I can say here's my variable b. I can choose where it starts and stops. So suppose I want to allow it to go, say, from -10 instead of -5 to +10. And my step size, I can make it tinier. Suppose I want to make it go in increments of 0.01. And I can also make it go horizontal or vertical. So I can make my slider appear different ways. Okay, now when I go to move this, once I click off of it and I grab the slider, you'll notice that I get much smoother movement for the values of the slider. And I can also go up here and click on here and actually type in a specific value for a slider. Like if I want to do 1.1, okay, it'll jump immediately to 1.1. So I do have the ability to control the sliders in a variety of different ways. All right, another thing that sometimes we like to do is to be able to create a piecewise defined function. So let's say, for example, let me insert a new problem, doc, insert problem, graphs page. Notice it's now problem 4, page 1. Suppose I want to put a piecewise defined function in. If I go to my math templates, I can do one piece. This looks like 3 pieces, but in fact it's however many you want to choose. If I click on that, it's going to ask me how many pieces. If I say I want only 2, it'll just give me only 2. But suppose I want to have something like x, and then here I put a condition on that. So let's say we want this to be x when x is, let's say, less than 1. So to get my less than key, I'm going to do my control equal sign over here, and I'm going to get less than 1. Tab. And let's say we want it to be x squared everywhere else. So I'm going to hit tab. In this case, I want when x is greater than or equal to 1. So I'm going to do control equals, get my greater than or equal to sign, click, equal to 1, hit enter. And now you see the piecewise defined function. It's a straight line here, and once it hits here, it actually becomes a part of a parabola. It's kind of hard to see that that's parabolic, but we can actually show that it is. Let's graph just plain old x squared on top of it. Let me just put in x squared. This will appear in red, and you'll see that my x squared is lying right on top of the blue key, the blue function right there when I get over into this region. So it really is part of a parabola stitched together with a straight line. So let me delete this guy so we can see it again. Okay, so piecewise, straight line, stitched together with a parabolic piece. So that's how the piecewise graphing works. And those are some of the basics of graphing. Later we'll talk a little bit about graphing data, things like that, when we start collecting data and using some of the lists and spreadsheet features.